You might look at that and think, oh, substitution. I've seen substitution before. It needs a more dramatic title. Solving systems. Awesome. This is awesome solving, friends. This is the first time, I think, where you'll go, I see what this algebra can do. Up till now, you could think to yourself, this algebra is just here to torture me. This is how math teachers get their kicks, by making us collect like terms, move x's over. Wait till you see what this can do. This is amazing. Is that selling it too hard and making it seem like it's going to be really difficult? No, I don't think so. With practice, I don't think this is a very difficult procedure at all. But it's really amazing what it accomplishes. So, learning goal, solving a system of linear equations by using an algebraic strategy. What's the difference? Yesterday we used a graphing strategy, and graphing has huge advantages. So if I make fun of it today, it's only because I'm teaching this today. Graphing has advantages, but solving by substitution, this is powerful stuff. So recall, the solution to a linear system is when a point satisfies both equations. So this whole chapter, we get 2 equations and 2 unknowns. If we had to drop that on you in grade 9, it would have seemed impossible to solve. We're starting to see some ways to handle that. And then given 2 linear relations, the ordered pair is the point of intersections. So this is yesterday's review coming up in one little picture. Here's what you did yesterday. You graphed the first line. Then you graphed another line. And then this point that they met up at, I'm really excited about my colors today, so I'm going all over the place with colors. This point where they met up was the point of intersection, or the solution. What was the only thing you really had to be good at to be able to handle this? What was the big move? Yes, I know about slope and y-intercept, but what was the challenging situation that came up? Well, maybe you didn't find it too challenging. Maybe that's why you're having trouble with that question. Negatives were a problem when we went to do what? What were we trying to accomplish when negatives started causing us a problem? Because negative in slope or negative in intercepts wasn't a big deal. Oh yeah, that's so true. Yeah, you're remembering the lesson so well. When the negatives went off the graph, that was a problem too, yeah. Yes, so danger. Isolating y. Maybe you don't think so. Maybe you're like, oh, I can isolate y. It wasn't a problem for me. I watched out for the negatives. It was good. But if you're having trouble with that, you're not alone. Plenty of people have trouble with isolating y, and I've got bonus worksheets if you need them, if the homework you had trouble with on certain questions. Anyways, back to today's lesson. The advantage of using a graph to solving a linear system. Very visual. You can see exactly what you're trying to accomplish. Second, graphing lines is easy. Well, okay. Graphing lines is pretty easy. Those are 2 gigantic advantages. Do not let me diss graphing during this lesson. What are the potential problems with graphing, though? I can think of 2. I've heard of 4, so there's lots of great answers here. What's the potential difficulties with graphing? I don't mean just y equals mx plus b. What? Decimals. Disadvantage. Doesn't handle decimals accurately.
All grade 9 students who have not yet registered for classes for next year, please go to Computer Lab 2124. That's all grade 9 students who have not registered for classes next year, go to Computer Lab 2124.
It'll handle decimals, graphing, but you'll have to guess what the answer is. Not guess, you have to estimate. Not accurate. Modern grade 10s should be thinking, no way they're using graphing to solve real life intense equations. Yeah, we're not using solve by graphing to launch a mission to Mars. That's not going to be accurate enough. We're not using solve by graphing to design iPhones. It won't be accurate enough. Okay, but very visual. Yeah. What other types of numbers are going to be a major league challenge if we encounter them? Fractions as well, yes. So I'll put under here decimals or fractions are going to be a challenge. So one more type of number that graphing is not going to deal with well. Percentages, decimals, fractions, absolutely all those numbers are a major league problem. Anything that's not a whole number or an integer.
Please excuse the interruption. Could all grade 10 students who have not yet registered for classes for next year please go to the library now? All grade 10 students to the library,
he
who
said.
have not yet registered.
If you haven't done your registration yet, you can go to the library. Does anybody else need to do registration yet? Yeah, some other people need to go? Do you have your, all you'll need is your registration info, like you know what that is? Okay. Shouldn't take long if you're just finishing up, no problem. What other types of numbers?
Big numbers.
Big numbers. Doesn't handle big numbers well. Well, okay, maybe you're thinking, as long as we make our scale go up by lots, can't I do big numbers? Yeah, but wow. Like you're gonna have this graph that goes out to 3 million. Maybe it goes from negative 3 million up to positive 3 million. Like that's gonna be a major problem. So what I'm gonna show you today, solve by substitution, doesn't care what numbers you're talking about. It doesn't care how big the numbers are. It will get the answers. So it's much more powerful. Now, like a lot of things in math, once we go away from visual, it'll be harder to understand what's happening. It won't be quite so obvious what we're doing. So that's a challenge. Okay. Well, that sets the stage, finally, for solving by substitution. Now, I really thought it over, and I didn't know whether to put this at the beginning of the lesson or the end of the lesson. It might be confusing when I put this up front. This is what I'm going to teach you today. This is the steps to solving by substitution. So no freaking out. As I explain it, if you're like, I don't really get what you're saying there, that's okay. That's it. I'm just like giving you a guide. Here's what I'm going to do today. Okay? And maybe you think this should be at the end. I would probably 50% agree with you. Maybe this should be at the end. Anyway, here it is. Here's my steps to solving by substitution. Number the equations 1 and 2. There's two equations, number them 1 and 2. Mathematicians usually use a 1 in a circle and a 2 in a circle. It's just a tradition. Yeah? You can number it other things, but that's what you'll see most people do. Isolate, look at okay. As soon as you see that word, you're like, this is why he was so on about isolate. Because isolate was needed for graphing, and now it's needed for substitution as well. It says isolate one variable, either x or y. You'll get to choose. Here, add that on into your note. You choose. You're like, how am I going to choose? Well, hey, that's going to be in the lesson. How am I going to choose which variable to isolate? We'll get to it in just a second. Substitute the expression into the other equation. What? Well, wait till you see. It's so good. Yeah. Solve the resulting linear equation. I'm going to put a smiley face here. Most people in substitution, once they get to that step, they cruise from there. Once they get it, that new equation, and you'll see how happy you're going to be with the equation. And then substitute the solve value back in to determine the other variable. What? I don't know. That's where it sort of falls apart. It's hard to keep track of everything I'm saying there. But I'm going to go through these steps. And then state your answer just like you did yesterday. State the answer when you're all done. And then check. I'll put a check mark there. Why wouldn't you want to check? When you're doing your homework, maybe period 2 is okay? Yes. Yeah. Maybe you check the answer in the back of the book just to make sure you got it right. If you're on a quiz or a test, you better do that left side, right side to make sure it works. Okay, no more intro. Let's get to it. Let's get right into one. This is a example 1. I don't think you have to copy anything right there. This is like your exemplar example that you can look back at and see the whole procedure once. So on a scale of 1 to 100, I hope after you see this, you are a 25. The first time through, you go, I sort of get what the plan is. Again, no freaking out until I start writing. That's when you can start going, do I understand everything he's doing? This is what it's going to look like to do solving by substitution. You're going to look at these two equations you're given, and you're going to number them, 1 and 2. So you know which one you're talking about. Then you're going to choose one of the variables to isolate for. I'm going to totally give it away. The one you want to isolate for is the one that doesn't have a coefficient on it, if possible. See that y right there? All the other ones have coefficients. You try and isolate for that, you're just asking for fraction trouble. So try to find one of the variables that is already sort of isolated. It doesn't have a coefficient at this moment. Rearrange to isolate it. And don't get hung up in the individual steps right now, because I'm going to do lots of the individual steps. I just want you to see the general structure. And what you find out is y is negative 2 plus 5x once you isolate that. Then take that. This is brilliant. This is brilliant mathematics. If this was a truly wonderful school, after showing you this line, I would then give you all $8. We'd all go get our favorite food, chicken pad thai maybe, slice of pizza maybe, and we just sit under trees and consider how wonderful our life is. This is a major mathematical breakthrough. You take that expression for y and you put it into this equation as the y. It replaces that y, and now you get an equation that only has x's in it. And I put that smiley face there again going, it's now not two equations with two unknowns. It's one equation with one unknown by replacing the y with a whole bunch of x stuff. Well, your algebra better be solid here, right? Now you see why we were torturing you with algebra along the way. It's for this moment. The idea is pretty simple, but your algebra better be there for you when you go to do it. Without getting hung up on the individual steps, now that you've got an equation for x's, you use your grade 9 techniques to solve for x. Once you have the x, you put that x into either one of the equations and get the y. Now remember what I said. On a scale of 1 to 100, after me explaining that, you should be about a 25. You go, okay, I get in theory what's supposed to happen, but I don't know if I can do it. Of course not. I'm not done. Now I'm going to go, okay, that's like this part. Yeah? We watched and got, okay, I see in theory what's supposed to happen. Give me the ball and let me give it a try. Over here, this is just left side, right side check. So let's not pretend that something's going on there. That's a statement. Let's not pretend something's going on there. Those parts are going to be straightforward. Finally, intro over. You've got this to look back at. You're like, tonight, this weekend, the day before the test, you're like, how does solve by substitution go? You can go back and look at this one, although I'm going to give you a lot more. All right, now listen. If at this point, you've barely got the fog out of your brain from your period 1 class, maybe you were sleeping through that lesson, you've wandered in here in a daze, and I've said a whole bunch of crazy stuff, you're a little concerned about the whole situation, don't be. Solve by substitution is not known as a particularly difficult procedure. Chill out. Give your head a shake. Reach down, do up your seatbelt, and we'll do one together very, very slowly. What's my goal here? On a scale of 1 to 100, I hope after this one you're like a 40. You're like, I sort of see what you're saying now. Very, very slowly. I'm talking to you, but I'm also talking to me. Very slowly. Step 1, number the two equations. This one's going to be equation 1, and this one's going to be equation 2. So when I'm talking about them, when I'm doing work with them, I now have them numbered. Yeah? We put the 1 and 2 in circles so we don't get confused with the 1s and 2s and 8s and 7s and stuff in the equation. They're in circles. They're not really part of the equation. Okay. Step 2. Look. Yes? Are you identifying the second equation as the one to work with? He's already a step ahead of me. He's looked at these and looked at the different variables available and tried to find one that will be easy to isolate the variable. If possible, we want one that doesn't have a coefficient. Will that always be possible? No, but we'll get to that. We warm up on some where it's pretty straightforward. Continuing my basketball analogy, we'll take some open shots first. We won't worry about if the defense is covering us. We'll get to that in a minute. For now, we'll work And I'll put a little underlining on there and going, look at that y. That's the one I want. So then I write something like this. Rearrange equation 2. See, I'm letting anyone who reads this know, including myself, if I have to look back at my own work, what it is I tried to accomplish. Now, for the sake of my notes, I'm not going to actually do any rearranging in the first step. I'm just going to rewrite that equation to get ready to isolate. And I don't want to lose you, so I really want to talk this out. If I'm isolating y, what's the thing I have to do here? What has to be accomplished? Minus 4x from both sides. I'm going to show that step. But you can skip this step. If this step's now confusing for you, you can skip this step. Here's what this step looks like to me. I'll color code it. I'm going very carefully here. Maybe you're like, I don't need that extra step. Thank you, Mr. Todd, for giving me that extra step. But mine, when I isolate, I'm so good at algebra now, mine looks like this. I jump right to here. That's the way I think about it. I move that 4x over, and it becomes subtract 4x. Is it good? Step 1 accomplished. I've isolated one of the variables. My choice. I chose y from the second equation. I like putting those in a box, me personally. I'm going to be looking for this equation maybe later, and putting it in a box helps me. That's an important equation. Now, here's where all the awesome mathematics lies. Again, after writing these next 2 lines, if this was a truly great school, we'd just go and sit under a tree and consider how wonderful mathematics is. Very carefully write this sentence, Mr. Todd. Substitute y equals 7 minus 4x into, okay, now this is just going to take a little bit of thought, a tiny bit of thought. I rearranged equation 2. So I'm going to sub into equation 1. Clear enough? I'm not substituting an equation back into itself. That's not going to accomplish anything. But if I sub it into equation 1, wake up, friends. Wake up. If you're only going to listen to one sentence all day, this is the sentence. This is the key to the whole procedure. I'm going to write equation 1. Ready? Equation 1. 3. Okay so far? It's got a 3 out there. What's the next thing it's got? X. Subtract. The next thing it's got is 2. The next thing it's got is y. Dun, dun, dun. Don't write y this time. That's not going to accomplish anything. What am I going to write in replace of y? 7 minus 4x. Mic drop, friends. Hands in the air. Raise the roof. It's all over. It's all over. That might not be clear yet. I understand. It might not be clear what I've accomplished yet. So in a second, I'm going to ask someone to, in their own words, phrase why that's so amazing. Now I'll continue. What's happening? I raised the roof there and lost my page. Equals 7. Can someone tell me in their own words why the world just changed? And I'm not joking. I'm not exaggerating. Our algebra world just changed with that step. What is good about this equation? I know there's some bad things. What's so great about that equation?
It's grouping like terms, and it's just 3 minus 4 minus 3, which is 1, so it's just x.
Oh yeah, he's about 11 steps ahead of me. I don't even know exactly what he said about the situation. But he sees the goodness of this. He said, we're going to collect like terms. We're going to solve for x. Yes? Let's just go a step farther with understanding what's accomplished here. We started with 2 equations with 2 unknowns. Impossibly hard, really. In this line of algebra, though, what do I have now? How many equations do I have? 1. And how many unknowns are in that equation? 1. We is happy. Look, here comes my happy face. A regular happy face is not enough. That's a full-on toothy smile. Oh, geez, that doesn't look happy. That looks creepy, doesn't it? I tried to make it extra happy, and now I made it a little bit creepy. We are so happy. Question. 3x minus 2y equals 8. Thank you. Oh, I was so excited about my silly jokes. I put the wrong number there. Now, I didn't do that on purpose. But that's the kind of thing that will go wrong in this homework all the time. Exactly that, where you go back and go, I didn't get the right answer. I got all the steps, it's not right. And then you got to scour over it line by line and find out where you put 7 instead of 8 or a negative instead of a positive. That's the kind of thing that goes on all the time. All right, well, if your regular equation solving is not the greatest, that's going to get exposed here. But you're going to work on it, so it's going to improve. So that's good news. What do I do here? I'm going to expand out the brackets. I'm going to multiply this negative 2 in. I get negative 14 plus 8x equals 8, not 7. Oh, don't let me away with it. Don't let me away with it if that's a problem. Is that okay, that distribution there? Let me write the arrows on there for you. I just took this negative 2 here, and I multiplied by 7, and I multiplied it by negative 4x. And let's go back to this again. Is that a negative 2 out front there, or is it subtract 2? It's whatever it needs to be. So it's subtract 2 when I read the question. It's negative 2 when I multiply it in, and then it comes back to being subtract again, and that's all okay. That's not a math trick. That's the way those positives and negatives and adds and subtracts work. What else can I do here? 3x and 8x, those are like terms. That's what Austin said. He said, oh, we're going to be collecting some like terms there. Life's getting better all the time. Every single line, you're like, this is getting better all the time. Now what? Add 14. Last step. And then divide by 11. Hopefully all that stuff is at least familiar, even if you're like, I'm going to have to practice that. I'm not quite as good at that equation solving as I want to be. The good news is every homework question is going to practice that, so you'll get another chance at it. Another smiley face, because it's like, oh, that's awesome. Is this better than graphing? In this question, I'm not sure. You might argue that graphing would be nicer here. I don't know the answer to that. I do know that if these numbers were 76, 54.2, and 6 million, this would just handle it. You'd just be carrying around bigger numbers. You wouldn't have any big challenges there. But that is not all, friends. That is not all, said the cat in the hat as he bounced on his ball. That only gives me the x. I now know x equals 2. Does anyone have any ideas what I could do with the x to find y? Like if only there was an equation that told me y's if I knew x's. Does anyone have any ideas what I could use to find the y if I had the x? X is 2. Oh, stop that. Stupid. Substitute the 2 in over here. And that's the part when I was explaining the big picture where you might have been confused. You're like, it's too much, it's too much. I know, it is too much all at once. But then when you actually go to do it, and you ask yourself, what do I do with x equals 2? I got to find y. The equations over here are yelling up and down like 7-year-olds on the hockey bench. They're jumping up and down going, put me in, I can do it, I can do it. So I'm going to write another awesome sentence here. Sub x equals sub. Ooh, maybe we'll have subs for dinner tonight, will we? All this talk about subs is getting me excited.
How much do they cost?
How much do subs cost? I don't know. They've cleverly made the app where I don't really have to look at the price, right? I can just, bloop, I just click it. Goes right to my Visa. I worry about it next month. Clever stuff they're doing. You don't have to hand them cash anymore. Sub x equals 2 into, now you can do what you want here, folks. I give this one another number. I call this equation 3. That's what I do. That helps me think it all through. And then I say, I'm going to sub that into equation 3. My 3 is a little nuts there, isn't it? Y equals 7 minus 4 times 2. Now I've got the y. No graphing. No graphing. I have several things left to do. Was anyone able to follow along enough to know what I would do now? What 2 things should I still do? Check, yeah. Why wouldn't you want to check? And I'm going to do that check in just a second. But I'm going to also state the answer. Therefore, the solution is 2 comma negative 1. Okay? So, we do a little checking though. I'll put that over here. Equation 1. Left side, right side. Back to the original equation. I forget what it was. 3x minus 2y equals 8. So 3 times 2 minus 2 times negative 1 equals 6 plus 2 equals 8. I'm so happy it worked for equation 1. Now, let's say you did make a little mistake in your algebra somewhere. It's possible that your numbers will work for the first equation but not for the second. So if you're really checking, you're checking both equations. And the second equation there was, I forget now, what was it? 4x plus y equals 7. So that's 4 times 2 plus negative 1, 8 minus 1, 7. Yes? Good stuff. Would I go through that check every question in the homework? No, I don't think so. I'd use the back of the book just to check as I go. And then every once in a while, I'd make sure, yeah, do I remember how to check? I don't know, like every 4th question, every 3rd question. You decide for yourself. If the first couple of times you do a check, you know exactly what you're doing, you don't have to do that very often. Would I do it on a quiz or a test? Would I ever? That'd be my most favorite step on a quiz or test because it checks the answer. Huh? How did we do? My goal on a scale of 1 to 100 is that I get you to a 40. 40 being, I get some of the steps. I get the theory. I don't know if I can do it myself yet, but I'm starting to get what the plan is here. Do we make it to 40? No. A couple people saying no. Good. Well, then I'm going to go slow on the second one. I only have 3 examples for you. And then I send you off for your Family Day weekend. This is the perfect homework for Family Day weekend. It's easy to get out of chores around the house when you have lots of algebra homework. Yes? You don't need extra homework. You just need the stuff I got. You take it out. You make it very visual that that's what you're doing. The best time is right as soon as dinner finishes because you know what's coming next, right? Dishes, putting stuff away, empty the dishwasher. You're there like, I can help. I'll do my homework later. Most parents are like, no. Sit and do your algebra homework, and this stuff looks good. Any parent looks over your shoulder is like, whoa, yikes. Don't let them watch this video, though, and I'm telling you this advice. Do you need more time here before we do another one, right? Top to bottom and go all through all this again? So if you missed that example, or if you're sort of not understanding it, here's the whole thing again. It's very repetitive. And lots of things in math are like that. They look very confusing, except they're so darn repetitive that you're just like, okay, I'll just try another one. Let me just try another one. And eventually you go, okay, I got it now. Step 1 in these. What would I do first, given these 2 equations? Yeah, do you see how she caught it by the way she said it? I'm going to arrange What? What am I going to rearrange? Oh, let's label them. Let's give them a label, 1 and 2. And I'm going to let her answer because she had the answer to the next one. But let me just rephrase the question now. What would I do next now that I have these two equations? Yeah, rearrange 1. Looming in the background is what happens if they've all got coefficients. Let's leave that. And that's why this lesson has substitution day 1 and it's got substitution day 2. Day 1, they're usually rigged up that you can look and go, oh, there's one of them in there. That's not too bad to rearrange for. And I'll underline it and go, here's the one I'm going to go after. It's almost isolated already. It doesn't have it's not like a 2x or a negative 5x. Certainly not ones with negatives in front of them. Oh my goodness, that's just asking for trouble. So I'm going to write this fancy sentence. I encourage you to write this sentence every time. Sentence. It's not really a sentence. This wouldn't be a sentence in English class, would it? This is a mathematical sentence. Rearrange equation 1. I'm going to rewrite the equation. You don't have to. You can start your rearranging right away. But for the sake of making a beautiful note to put online, I'll just show. I'm going to work with equation 1. Now that I've got equation 1, and this is weird because I'm not isolating y, and that might throw you off a little bit. I said you had your choice, and we're going to choose x this time. What do I have to do to isolate x? Just minus the 3y. Move that over. I'm not going to show the extra step this time. If you're still doing that extra step, that doesn't make you a bad math person. It probably makes you a better math person. But most people, I think, are starting to see that as adding 3y moves over and becomes subtracting 3y. What would you do next? What would I do next now that I've accomplished that monumental equation? Yes, he says substitute it in. Me personally, when I get something isolated, I put a box around it to go, hey, that's big. That's an important equation. So I'm going to box it so that I'm going to look for it later. It's nicely boxed. So that's just my little advice. But he's right. He says substitute. And until you're really good at this, write this just the way I'm writing it. Substitute x equals 11 minus 3y into, okay, just a little thought here. Those of you who said, are you at a 40 out of 100 understanding here? Those of you who are below 40, really pay attention to this. I rearranged number 1. So really that is a version of equation 1. So when I go to substitute in, I've got to substitute into the other equation, which is equation 2. Okay? There's something satisfying about that. I worked with 1, now I'm going to work with 2. Now, if you want to jump from a 40 understanding to like an 80, it's all right here. This is the line that does everything. Does anyone want to state? Anyone seeing through this and can now state what to do next? Yes, and I'll give you a fancy sentence to say it. Substitute. Oh, I wrote that. Substitute x minus 11y into equation 2. So here I go writing equation 2. 4. Do this slowly as you're getting used to it. He said it out loud. 4 x, not x. I mean, it is x, but it's what I found out x was. X is this crazy thing, 11 minus 3y. And I'm going to underline that and underline that so you can see where that's coming from. Instead of writing x, I write what I found x to be. If you're rewatching this on a video later, I'm going to say that sentence again so it's clear what I'm doing. Instead of writing x, I'm going to write what I found out x was in terms of y. So that's 4x minus 7y. Focus this time, do not make a mistake. Let's double check that I did that. 4x minus 7y equals 6. What is so amazing about that equation? It's got problems, I know. It's got negatives, it's got brackets, it's got all sorts of stuff. But what's amazing?
There's only one variable.
There's only one variable. That's what you should be walking around the hallways of St. John's saying at lunch today. Yeah? People walking by and say, how's your day? There's only one variable. And they're like looking at you like, What? Okay, there's only one variable. My problems are over. There's only one variable. It's so good. Anybody who knows better will be like, substitution. You're like, yeah, substitution. We're having subs for dinner tonight. Mr. Todd said we had to have subs for dinner tonight to celebrate what good substitutors we are. All right, but if your irregular equation solving is not great, you're going to want to listen to these steps. When there's brackets, we do the distribution. This 4 gets multiplied by each of these in the brackets. So I get 44 minus 12y minus 7y equals 6. Collect the like terms. In this case, that's what I would do next. Maybe you think you should move the 44 over first. That's fine. Those two steps are sort of interchangeable. But if I collect the like terms here, I get 44 minus 19y equals 6. And move the 44 over. Six minus 44, you get your calculator out, you hammer that in there, negative 38. Then what's the next step? Divide by negative 19, and this is a key moment because you're like, oh, I hope this works. I hope I get a whole number. Is there homework questions? Is it possible to get fractions here? Yes. Yes, it is. I don't want you to think it's automatically wrong because you get a fraction. But generally, in this chapter, we try to protect you from fractions mostly because it's not the point of the questions. The point of the questions is, how do I do this method? And the fractions can distract from that, but there will be fractions around once in a while. Y equals 2. Ooh, I like putting a box around that too. That's a major breakthrough. I now have the y value. And who's got the method to get the x value? Yeah, just take this y and sub it in. Actually, you're allowed to sub it in anywhere. But substitution is nice. Usually there's a nice equation to sub it into that you already built. So it usually goes right in here. I like calling it equation 3. You do not have to do that. That's just my personal management technique. So then I write something like this. Sub y equals 2 into equation 3, which is really just equation 1, but rearranged nicely for this situation. X equals 11 minus 3 times 2. Hopefully these steps aren't a big problem for you. I get x equals 5. What two things do I have left to do to finish this out? Write my sentence. Therefore, and the last one I wrote, the solution is, which is absolutely true. This time I'm going to write, therefore, the point of intersection. Oh my goodness. You want me to write out point of intersection in every question in my homework? No, mathematicians don't. There's a short form for point of intersection. We all write POI. So I give you that short form now for point of intersection. Therefore, the point of intersection is 5, 2. What's the other thing I should do? Check. I'm going to give you an option for checking that I think you should do. This is what I would do if I was doing this homework. First question, I would check using the left side, right side check. The next question, I'd check and make sure I know how to use Desmos to check this. Let's check this out. Let's check this out. If you don't have Desmos, get it downloaded. Desmos, graphing calculator. Watch this. What was the first equation originally? X plus 3y equals 11. Now notice, look, Desmos doesn't care about y equals mx plus b. It's like, I can do that. Just give me the equation, and I'll give you the line. What's the other one? 4x plus y equals 7. And on Desmos, if I go and just click on that point, see, it knows what I'm looking for. Something's wrong. Look it, something's wrong. This is exactly why we do this. X plus 3y equals 11. 4x minus 7y. I don't know if I heard you wrong or what, but there it is. And then if you click on the, something's still wrong. X plus 3y equals 11.
It's 6.
4x minus 7y equals 6. And then if I click on that point, it shows the point 5, 2. Yeah? Another great way to check. You can't do this on the test. You don't have Desmos on the test. So you want to make sure you're good at the left side, right side check. But this is really good so you can visualize that even though we're doing algebra, we're finding an intersection of two lines so that you're not losing track of that and all that. It's easy in the algebra to lose track of what we're trying to accomplish. It's an algebraic technique to find the point of intersection of two lines. Do you have questions before we do the last example? What is the last example? Oh, the last example's, I finished with an easy one that might mess you up if you're not careful. This is nice. They're both already isolated. But something weird looking happens. It's not a problem, but it's weird looking what happens. Since they're both already isolated, I can just say sub 2 into 1. This one's all ready to go. Now I'm going to write this line, and if it messes you up, yeah, I know. It looks weird, but stare at it long enough that you're either happy or that you have a question. I take the second equation and substitute it right into the first equation. That is where I saw y in the first equation. I didn't write y. I wrote negative 3x plus 11, which is what I found out y is. Well, I didn't find it out. It was already there. Okay? So that one's so easy it's hard, I think, is the problem with it. But what is so awesome about this equation? It only has one unknown in it. It has x's on both sides, though. So we got to know what we're doing here. Let's be careful a little bit. Bring the 2x over, right, carefully. Maybe you're even faster at this than I am. I hope you are. If you're not, you're like, I'm doing every one of these this weekend to make sure I get good at substitution, I get good at my old equation solving, get good at checking all of those things. Now, I did that fast on purpose, not to be a giant jerk, but to challenge you. If you look at those steps and you're like, what did you do there? What did you do there? That's okay. It's not panic time, but it is time to set aside some time this weekend to going, I better practice these because those steps were a little too fast for me. What did I do? I moved the 11 over and it became subtract 11. 1 minus 11 is negative 10. And then I divided by negative 5. What now? What do I do with the 2 to get the y value? Once I have an x, what do I do with it to get y values? It's more substitution. You see why it's called substitution? Like every step is like sub, sub, sub. You're just subbing this into that until sub it back into that. Great method. So sub x equals 2. And actually, as it turns out, in this question, you could sub it into either one of these. They'll both give, I'm going to look real quick, they both will give answer 5. So that's nice in this particular one. So I'm going to sub it into the first equation, because I think the first equation looks a little easier. That's the only reason I chose that one. So y equals 2 times 2 plus 1, y equals 4 plus 1, y equals 5. Therefore, the solution, I'm going back to saying it that way, but you can say it whichever way you want, is 2, 5. then check it to make sure. But maybe in this one, you just check the back of the book, or you check the worksheet answer and go, okay, I'm going to check there. You got multiple ways to check. Which one do you need for the test? Well, left side, right side, check. That's the one you want to, so make sure you're able to do that. I don't think it's a particularly difficult procedure. What questions do you have about that on a Friday before a long weekend? Aren't you excited? Questions 3 and 5. What would I do? Were it me facing your long weekend, I would do question 3 tonight. I'd do question 5 on Saturday. Take Sunday, Monday off. You know, you're not overrun with homework all weekend, but I encourage you. I know what's coming next week. It's not that it's so hard, but we're going up a set of stairs. If you get down a step behind the rest of us, the lessons aren't going to make sense. Then the homework's not going to make sense. It's going to spiral backwards on you. So get on top of this, and the weekend is the perfect time to do that.